To solve the equation 14 cosine 2x equals 14 cosine square x minus 9, you're going to use the double angle identity for cosine. And which one you're going to use is going to depend on how you perceive the question. So in this case, I have cosine square, which means I don't need to see a sine square, which means the identity I will be using is cosine 2x equals 2 cosine square x minus 1. So that is the identity that I will be using, the one that doesn't have a cosine square. So I will not make my life miserable. So now we're going to substitute this identity into the equation. We will get 14 2 cosine square x minus 1 equals 14 cosine square x minus 9. Now we're going to distribute the 14 inside, so we will get 28 cosine square x minus 1 minus 14 equals 14 cosine square x minus 9. Now to solve this equation, we're going to make the right-hand side 0. So we're going to say 28 cosine square x minus 14 minus 14 cosine square x plus 9 equals 0. Notice how these are like terms, and negative 14 and 9 are like terms. So we're going to say 28 cosine square x minus 14 cosine square x, that is 14 cosine square x minus 5 equals 0. Negative 14 plus 9 is minus 5, or negative 5. Now, to solve this equation, we need first to add 5 to both sides of the equation. So we will get 14 cosine square x equals 5. Now we're going to divide both sides by 14. We will get cosine square x equals 5 over 14. Now, we're going to take the square root for both sides of the equation. So you'll take square root here, square root here. Don't forget that when we take the square root, we have to include positive and negative. Because if x squared is equal to 9, then either x is going to be equal to 3 or x is equal to negative 3. Because both of these solutions, after you square them, you end up with 9. So same concept here. Now we have cosine x equals positive or negative square root of 5 over square root of 14. We can split the radical. Now we have two cases. We have either cosine x is equal to positive square root of 5 over positive square root of 14, or cosine x equals to negative square root of 5 over square root of 14. Please don't put negative here. Negative either goes up or down or in the middle. Now in the first case, if we have cosine x equal to positive square root of 5 over 14, remember that cosine is positive in the first quadrant and the fourth quadrant, which means we can say that we can take the arc sine for both sides of the equation, or we can use the arc sine or the inverse cosine function. So we're going to say x equals to the inverse cosine of square root of 5 over square root of 14, which happens to be in the first quadrant. And in this case, and then in the fourth quadrant, this is basically the same amount that goes here. We're gonna take it in the fourth quadrant, so it's gonna be 2 pi minus that amount. So x is equal to 2 pi minus inverse cosine of square root of 5 over square root of 14. So that is a second solution. In the other case, notice how the cosine is negative in the third quadrant and the third quadrant. So in the third quadrant, we can say the same solution here is the same one here. So it's going to be pi minus that amount. So the solution here is going to be pi minus inverse cosine of square root of 5 over square root of 14. And then the other solution is going to be in the third quadrant, which is basically the same amount added to pi. So x is equal to pi plus cosine inverse of square root of 5 over square root of 14, or inverse cosine. Or you could say arc sine instead of inverse cosine. And these are the 4 solutions. In general, you can generalize and you can say this solution is general if you add multiples of 2 pi to it, such that n is an integer. Same with the second solution, same with the third solution, and same with the fourth solution. Hopefully you get the idea. So that is in general, but in over just one interval from 0 to 2 pi, the solutions are going to be these 4 solutions basically. I hope this helped, and I will see you in a different video.